Okay, so we are diving into some special quadrilaterals, and the first one we're going to talk about is a parallelogram. Thank God there is a symbol for parallelogram, which is that. So in other words, you do not have to write out the word parallelogram all the time. A parallelogram, by definition, it is a quadrilateral. I usually just abbreviate quadrilateral, quad. It's a quadrilateral with both pairs of opposite sides parallel. If you remember from some parallel lines and those special angle relationships, this is just building on. So if we have a parallelogram, then we know that these sides are parallel, and those sides are parallel. So if I were to label a parallelogram, first of all, when you label it, so if I say that this is parallelogram ABCD, it is very important that you start somewhere, obviously, and then you go consecutively. So go around the figure. Do not do A, B, C, and then bounce up to D. So A, B, C, D as you walk around it. So I could say that AB is parallel to CD, and that AD is parallel to BC. That is a parallelogram. Building on to this idea, it says opposite sides. So these two would be opposites, and these would be opposites. And we also have a lot of other special things with when this is the situation. So here are some properties. So other properties of a parallelogram. We also know that both pairs of opposite, I usually abbreviate opposite, OPPO, both pairs of opposite sides, not only are they parallel, but they are congruent. So I know that AB would be congruent to CD, and AD would be congruent to BC. Another property I know is that both pairs of opposite angles are congruent. So from that, I can say that angle B is congruent to angle D, and angle A is congruent to angle C. Markers here. So I could add all the tick marks on the diagram. So I'm not going to, because I have to do something else. I don't want a whole bunch of stuff on here. So AB would be congruent to CD, so I could use my tick marks. AD is congruent to BC, so I could use my tick marks. This is probably the one that people mess up the most, and that is the fact that diagonals bisect each other. So what that means, going back to this diagram, BD would be a diagonal, and AC would be a diagonal. They bisect each other, which means they cut each other in half. So this little piece would be congruent to that piece, and this little piece would be congruent to that little piece. Notice I did not use the same number of tick marks because all of these two are the same and these two are the same. just so we have something to talk about, I'm going to make this an F right in between. So if diagonals bisect each other, there's a couple things I know. I know that F is the midpoint of both AC and BD, and I know that DF is congruent to FB, and AF is congruent to FC. If we go back and think about parallel lines and all the special relationships, another special relationship is that consecutive angles are supplementary. So kind of just doing a quick sketch of what's up above. Okay, so if I have a parallelogram here, and we have G, H, J, and K, I would know that G and H and K, so G and J are congruent from before, H and K are congruent before, but now I also know that the measure of angle G plus the measure of angle H equals 180, and I can go the other way, that the measure of angle G plus the measure of angle K equals 180 degrees. So any angle you have and the consecutive angles that are by it are going to be supplementary and equal 180 degrees. And we are going to try a couple problems. So if I have, let's make this example 1. If I have a parallelogram, so I'm telling you that it is a parallelogram, and I know that this is 3x and this is 120. Because in a parallelogram, I'm going to put given parallelogram, because in a parallelogram both pairs of opposite angles are congruent, then they're equal, so I can set them equal to each other. So I could find out that x would equal 40. I could also, if this is 15, and let's say this is 3y, I could find out what y is, because both pairs of opposite sides are congruent, so 3y equals 15, so y would have to equal 5. And you could have, if this say is 10, find z. So z would equal 10 because both pairs of opposite sides in a parallelogram are congruent. Okay, so we are going to do a warm-up. This is what I want you to come to class with completed, so we'll label this as activity 1. I'm going to give you a parallelogram of ABCD. So I'm going to start A down here just for the heck of it. A, B, C, and D. And because it's a parallelogram, we know that both pairs of opposite sides are parallel. I want you to find some of the missing measurements. I'm going to tell you that angle B is 127. CD is 2x minus 3. And AB is x plus 2. So I want you to find the measure of angle A, the measure of angle D, X, and the length of AB. And let's give those, actually I'm going to give you one more in here. I'm going to put this segment in here. I'm going to dot this one, this diagonal, just so you don't lose that that's 127 degrees up there. If this, I'm going to put this as an E. So if AE equals 8, then I want you to find EC, and I want you to find AC. And that will conclude what you are doing for tomorrow, so make sure you come to class with the diagram and those 6 little tidbits completed.